All right, so part two expands this idea of taking this table that we've discovered, doing the Cartesian coordinate system, or x comma y, and now we're going to try to build onto that concept with our equation that we are kind of developing soon. So I want you to kind of look at input and output. Now remember, a function is, it's for every input you get exactly one output, right? For every input I put, I get one output. So that's what a function is again. So I want you to think about these two words called an input and an output. So I want you to kind of think about these two as well. This is kind of your x's, and these are going to be your y's. So your inputs are going to be what you put in for your x's. Your output is what you're going to have for your y's. So remember, if I put in something, I get out something. So let's make an example out of this that's kind of maybe really good with this. You're working at a job, and let's say you haven't started your job yet, or maybe you haven't started the week. And so they're paying you, let's say maybe your pay is, let's say $10. Just make the numbers easy for now. Let's say you're paying $10 an hour. They're paying $10 an hour. You haven't worked yet. Maybe you haven't started, so you haven't have any hours yet. Well, let's think about this. If you haven't worked yet, so let's say you're at 0 time. You're at 0 time. You didn't put any work in yet. Come up to your T table, and why don't we put our input at 0? How much money have you made? Well, if I put in 0 time, if I'm getting $10 an hour, but I haven't put any time in, well, my output is going to be 0. Because I haven't worked, I haven't did anything. So I put in 0 time, and I get nothing. So now the day goes on, I work 1 hour. So I work 1 hour. How much did you make? Well, if you get $10 an hour, 1 hour you get $10. Well, in 1 hour, you get $10. And if you want to, you could put a little dollar sign on them just to help you out. Or you can do this too. You can say the input is hours, and you can say the output is dollars. So now the day goes on. I work 2 hours. How much are you earning? $20, right? I work 2 hours, I get $20. Cool. I work 3 hours. How much are you getting? $30, right? And just keep going up. And I'm hoping you see a pattern. And if you want me to go on, that's fine. So 4, we got 40, and then on. You see a pattern. I'm hoping you're seeing a pattern. So this is kind of the idea, what we're trying to kind of come up with. We're taking some kind of word problem, and we're putting it into some values. And maybe this is kind of what we do when we're trying to get some data from people. You know, the census does this every 10 years. You know, they go out and then they say, okay, I want to go with this house, this house, this house, this house, this house, and then they're going to record data from those families. That house right there has one person in it. That house right there has 10 people in it. Just something like that. Now, that's just how we're building data. So that's kind of what the census is doing in a way, is trying to gather household data and goes from there. So that's kind of what we're doing here. We are saying that we are getting paid $10 an hour from a job, and every hour we're getting $10 added on. So this is kind of what we're doing. We're developing this. So let's take this idea and go over here to what we call our Cartesian coordinate system that you should be kind of familiar with. So let's put this into theory of this, okay? So we're going to take this idea and we're going to develop it. So remember, this is going to be your x. This is going to be your y's, correct? Sorry, your x's. My fault. This is going to be your x's. Well, this is going to be your y's. So your y-axis always, and your x-axis always. Remember, we always graph x comma y. So this goes on forever. Some teachers are kind of crazy about this, so these go on forever. So let's put a few points on this graph. And when I mean a few points, let's call this here point 1. And let's call this point 2. So we get 2 points on our graph. And by the way, these are all units of 1. These are all units of 1. What I mean by that, you go 1, 1, 1, 1. You don't skip or anything like that. It's all by unit spacing by 1. Now, we have 2 points. So remember what we do first. If this point here, what do we graph first? The x's, right? So this is going to go x1, because that's the first point. y2, that's the second point. Or point, this should be x, y. Yes, they should be negative, you're right. This should be negative and this should be negative. Because remember, you're down, negative, negative. But let's play with the theory first. We're trying to develop some kind of equation out of what our data is. Well, this point here, I'm going to change one thing actually. This, because I can kind of see the confusion. Let's do this. I'm sorry if you wrote this down, but this would be a lot better. Then I won't get questioned on this. Then this will make it all positive. Then this is the first quadrant. Remember, of our graph, this is our first quadrant. This is our second quadrant, third quadrant, fourth quadrant. The reason we're doing it in the first quadrant, because remember, it's all positive. Sorry about that. This is all positive. So if you want to, this is all positive. So we don't have to deal with negatives. If we did it the other way, I would have to pretty much include negatives because it would actually be that theory up there. But anyway, so point 1, point 2 isn't that going to be x2 x2, y2. Remember, our first point, our second point. Okay, got all that cleared up. Now, let's work on something here. Let's draw, what is our relationship between this point and this point? Well, what if we draw a line? Between those 2 points. Then we have something vertical, or not vertical, linear, which is a line. Linear means a line. Now, we have this point and this point. Can we think about some kind of association or relationship between these 2 points? So here's the thinking. I'm trying to get from this point to this point. How do I going to do that? I'm going to have to do some moving. So I'm going to start here, and what I'm going to do is that I'm going to do a thing called rise over run. So my first thing is going to do, just watch how I'm going to do this. I'm going to go on my y's, I'm going to go up to about where that point is. So I'm going to go so we can call this my rise. I'm rising. Okay, I'm rising about to this point. Now, since I'm about equal with that point, I'm going to run to it. So I'm going to go, I'm going to run to it. And that's kind of the idea. So I'm going to what we call run. So putting this together, when I rise, so my rise over, I guess I should use this instead. So rise over run. Well, let me ask you something. When I rise, what way am I going? I'm going up, but I'm also going in the vertical fashion. So I'm only using what? I'm only using the y's. I'm only using the y's. I'm not using the x's. X's are going this way, but I'm going this way, so I'm only using the y's. So what I'm going to do is that if I'm going from this point to this point, or this point to this point, well, technically I'm doing this. I'm subtracting distance, right? You're getting closer. So this should be y2 minus y1. Because I am not doing any x's, I'm just going up. And I'm subtracting, pretty much I'm subtracting these distances because I'm trying to get closer. Well, let me ask you something. If I'm running, I'm only going this direction. I'm only using the x's, so I'm going to take these 2 points and subtract them too. So I'm going to be doing something like this. I'm going to be subtracting them. And so that's what I get there. So I'm rising here, only using the y's, and I'm then going to run and only use the x's. And this is kind of what we call this formula, or this equation that we really developed in our theory. We develop what we call the rate of change. This is what we call the rate of change. Now, the rate of change is something that we did on this problem here. The rate of change is something we did here. And what is that? Well, let me ask you something. You worked 0 time, you got $0. You worked 1 hour, you got $10. You worked 2 hours, you get 20. What's going on there? For every hour, you get $10. Well, that's what we call the rate of change. So to close this out, go back over here real quick. From there to there, what's the difference? From 0 to 10, what happened? It went up by 10. From 0 to 1, what happened? It went up by 1. From 10 to 20, it went up by 10, right? From 20 to 30, it went up by 10, right? From 30 to 40, it went up by 10, right? From 1 to 2, it went up by 1. From 2 to 3, by 1. 3 to 4, by 1. Now, for the final, remember how we said rise over run? Or the y's divided by the x's? Look right here. The y's are all 10, right? Look at the x's. They're all difference by 1s. So, if you take our equation and do something like this, our y's divided by our differences, you get it. And this is what we call the rate of change. Later, it's going to be called something else. That's pretty much part 2 of this. So we're working through this. We pretty much got our formula or our theory now, or maybe our explanation of it. And now we're going to go on with this and make more use of this. So hopefully you enjoyed this. Watch this again if you need to.